pom.xml in Maven. Now we are focusing on pom.xml. A project model or POM is the fundamental unit of work in Maven. It is an XML file that contains information about the project and configuration details used by Maven to build the project. It contains default values for most projects. Examples for this is the build directory, which is a target, source directory, which is src/main/java, the test source directory, which is src/test.test/java, and so on. When executing a task or goal, Maven looks for the POM in the current directory. It reads the POM, gets the needed configuration information, then executes the goal. Here you can see POM overview. Here the asterisk element with asterisk element may be overridden, at least mostly, by profile element settings. And elements with here element with double asterisk profile elements are the asterisk dash suffixed elements. Here this sign contains elements for meant inheritance. Maven projects dependencies, builds, artifacts, all of these are objects to be modeled and described. These objects are described by an XML file called a project object model. The POM tells Maven what sort of project it is dealing with and how to modify default behavior to generate output from source. In the same way, a Java web application has a web.xml that describes, configures, and customizes the application. A Maven project is defined by presence of pom.xml. It is a descriptive declaration of a project Maven. It is the figurative map that Maven needs to understand what it is looking at when it builds your project. You can also think of pom.xml as an analogous to Makefile or an ant build.xml. When you are using GNU Make to build something like MySQL, you will usually have a file named Makefile that contains explicit instruction for building a binary from source. When you are using Apache Ant, you likely have the file named build.xml that contains explicit instruction for cleaning, compiling, packaging, and deploying an application. Make, Ant, and Maven are similar in that they rely on presence of a commonly named file such as Makefile, build.xml, or pom.xml, but that is where the similarities end. If you look at Maven pom.xml, the majority of POM is going to deal with descriptions. Where is the source code? Where are the resources? What is the packaging? If you look at an ant build.xml file, you will see something entirely different. You will see explicit instruction for tasks such as compiling a set of Java classes. The Maven POM is declarative And although you can certainly choose to include some procedural customizations via the Maven Ant plugin, for the most part you will not need to get into gritty procedural details of the build if your project's built. POM is also not specific to building Java projects. While most of the while Maven default plugins are targeted at building jar artifacts from a set of source, test, and resources, there's nothing preventing you from defining a POM for a project that contains C# resources and produces some proprietary Microsoft binary using Microsoft tools. We have established that the POM describes and declares it is unlike an ant or make in that it doesn't provide explicit instructions, and we have noted that POM concepts are not specific to Java. Here you can see the project object model and overview. POM contains 4 categories of description and configuration. The general project information. This includes a project name, the URL for a project, sponsoring organization, a list of developers and contributors, along with your project, along with your contributors, along with the license for a project. In build settings, in this section we customize the behavior of the default Maven build. We can change the location of sources and sets and tests. We can add new plugins. We can attach plugins goals to the lifecycle, and we can customize the site generating parameters. Build environment. The build environment consists of profiles that can be activated for use in different environments. For example, during development, you may want to deploy to a development server, whereas in production you want to deploy to a production server. The build environment customizes the build settings for specific environments. And is often supplemented by custom settings.xml in title/.m2. And POM relationships. A project rarely stand alone. It depends on other projects, inherits POM settings from parent projects, defines its own coordinates, and may include submodules. And if we reconsider this, POM stands for Project Object Model. It is an XML representation of a Maven project held in a file named pom.xml. When in the presence of Maven folks, speaking of a project is speaking the philosophical sense beyond a mere collection of files containing code. A project contains configurable files as well as the developers involved and roles that they play, and the defect tracking system, the organization and licenses, the URL of where project lives, the project dependencies, and all of other little pieces that come into play to give code life. It is a one-stop shop for all things concerning the project. In fact, in Maven world, a project does not need to contain any code at all, merely a pom.xml. The POM contains all necessary information about the project as well as configurations of plugins to be used during the build process. It is declarative manifestation of who, what, and where, while build cycle is the when and how. That is not to say that POM cannot affect the flow of the life cycle. It can. For example, by configuring Maven-Antran plugin, one can embed Apache and task inside the POM. It is merely a declaration, however, whereas a build.xml tells and precisely what to do when it is run procedural. The POM states its configuration declarative. This the external force causes the lifecycle to skip the ant plugin execution. It does not stop the plugin that are executed from doing their magic. This is unlike a build.xml file, whereas tasks are almost always dependent on the lines executed before. Here, Maven coordinates. The POM defined above is the bare minimum. Here group ID colon artifact ID version group ID colon artifact ID version group ID colon artifact ID colon version are all required field. All the group ID and version do not need to be explicitly defined if they are inherited from a parent. These three fields act much like an address and timestamp in one. This makes a project place in a repository act like a coordinate system for Maven projects. Project ID, this is generally unique amongst an organization or a project. For example, all core Maven artifact do well should live under the group ID org.apache.maven. Group IDs do not necessarily use the dot notation. For example, the JUnit project. Note that the .-noted group ID does not have to correspond to package structure that the project contains. It is, however, a good practice to follow. When stored within a repository, the group acts much like the Java packaging structure does in an operating system. The dots are replaced by OS-specific directory separators such as / in Unix, which becomes a relative directory structure from the base repository. Artifact ID. The artifact ID is generally the name that the project is known by, although the group ID is important, people within the group will rarely mention the group ID in discussion. It along with the group ID creates a key that separates this project from every other project in the world. At least it should. Along with the group ID, the artifact ID fully defines the artifact's living quarters within the repository. As an example, my dash project lives in $m2 underscore repo /org /codehouse /mojo /my project version. This is the last piece of the naming puzzle. Group ID : artifact ID denotes a single project, but they cannot delineate which incarnation of the project that we are talking about. Do we want JUnit : JUnit of 2008 version 4.12 or of 2007 version 3.8.2? In short, code changes. Those changes should be versioned. In this element keeps those versions in line. It is also used within an artifact repository to separate versions from each other. For example, my dash project version 1.0 files live in the directory structure $m2 underscore repo /org /codehouse /mojo my project /1.0. These three elements given here to a specific version of the project here, letting Maven know who we are dealing with and when it's in its software life cycle we want them. With regarding packaging, now that we have our address structure of group ID : artifact ID : version, there is one more standard label to give us a really complete what, that is project packaging. For example, pom.org.codehouse.mojo my dash project 1.0 define can be packaged as a jar. We could make it into WAR by declaring a different packaging. When no packaging is declared, Maven assumes the packaging is default jar. POM relationships. The most powerful aspect of Maven is its handling of project relationships. This includes dependencies and transitive dependencies, inheritance, and aggregation. Multi-module projects. Dependency management has a long tradition of being a complicated mesh for anything but the most trivial of project. Jarmageddon quickly ensures as a dependency tree become a large and complicated. Jar hell follows, where versions of dependencies on one system are not equivalent to the versions developed either by wrong version given or conflicting versions between similarly named jars. Maven solves both problems through a common local repository from which to link projects correctly, versions and all. Dependencies. The cornerstone of POM is its dependency list. Most projects depends on others to build and run correctly. If Maven does for you, this is if all Maven does for you is manage this list, you will gain a lot. Maven download and links the dependencies on compilation as well as on other goals that require them. As an added bonus, Maven brings in the dependencies of all those dependencies, transitive dependencies, allowing your list to focus solely on dependencies that your project requires. One of inheritance, one powerful addition that Maven brings to build management is concept of project inheritance. Although in build systems such as Ant, inheritance can be simulated, Maven makes project inheritance explicit in the project object model. And the super POM, POM, similar to inheritance of the objects in object-oriented programming, POMs that extend parents' POM inherits certain values from the parent from that parent. Moreover, just as Java objects ultimately inherits from java.lang.object, all project object models inherits from a base super POM. Dependency management. Beside inheriting certain top-level elements, parents have elements to configure values for child POMs and transitive dependencies. One of these elements is dependency management. It is used by POMs to help manage dependency information across all of its children. If my-parent project uses dependency management to define a dependency on JUnit: 4.12, then POMs inheriting from this one can set their dependency giving the group ID equal JUnit and artifact ID equal JUnit only, and Maven will fill the version set by the parent. The benefit of this method are obvious. Dependency details can be set in one central location which propagate to all inheriting POMs. Aggregation or multi-module. A project with modules known as a multi-module or aggregator project. Modules are projects that this POM lists and executed as a group. A POM package projects may aggregate the build of a set of projects by listing them as modules, which are relative path to directories or POM files of those projects. Properties are the last required piece to understand POM basics. Maven properties are value placeholders like properties in Ant. Their values are accessible anywhere within a POM by using the notation $, open curly brace, close curly brace where X is the property, or they can be used by plugins as default values. And in this diagram you can see properties here. Build settings. Beyond the basics of POM given before, given here, there are two more elements that must understood before claiming basic competency of the POM. They are built element that handles things like declaring your project's directory structure and managing plugins, and reporting elements that largely mirrors the built element for reporting purposes. The built, according to the POM 4.0.0 XSD, the built element is conceptually divided into two parts. There is a base build type which contains the set of elements common to both built elements, the top level built element and the project, and the built element and the profiles covered profiles. There are And there's a build type which contains base build set as well as more elements on for the top level definition. The basic build element set. Base build is exactly as it sounds, the base set of elements between the two built element in the POM. Resources, another set of built element is specifying where resources exist within your project. Resources are not usually code. They are not compiled, but are items meant to be bundled within your project or used for various other reasons such as code generation. Plugins beyond the standard coordinate of group ID colon artifact ID colon version. There are elements which configure the plugins or this build interaction with. Plugin management is an element that is seen along side plugins. Plugin management contains plugin element in which the same way, except that rather than configuring plugin information for this particular project build, it is intended to configure project builds that inherit from this one. However, this only configured plugins that are actually referred within the plugin element in the children or the current POM. The children have every right to override plugin management element definitions. The build element set, the build type in the XSD denotes denotes those elements that are available for the project build. Despite the number of extra element 6, there are really only 2 groups of elements that project build contains that are missing from the project from the profile build: directories and extensions. Directories, the set of directory element live within the parent build element, which set various directory structures for the POM as a whole. Since they do not exist in profile build, these cannot be altered by profiles. Extensions are a list of artifacts that are to be used in this build. They will be included in the running build class path. They can enable extensions to build process, such as add an FTP provider for the vegan transport mechanisms, as well as make plugins active which make changes to the build lifecycle. In short, extensions are artifacts that are activated during build. The extensions do not have to actually do anything for contain mojo. For this reason, extensions are excellent for specifying one out of multiple implementation of common plugin interface. Reporting contains the elements that correspond especially for the site generation phase. Certain Maven plugins generate reports defined and configured under report element. For example, generating Javadoc reports. Much like the built element's ability to configure plugins, reporting commands the same ability. The glaring difference is that rather than fine-grained control of plugin goals within the executions block, reporting configures goals within report set elements. And subtler difference is that a plugin configuration under the reporting element works as a built plugin configuration. Although the opposite is not true, a built plugin configuration does not affect a report plugin. Report sets. It is important to keep in mind that an individual plugin may have multiple goals. Each goal may have separate configuration. Report sets configure execution of a report plugins goals that does this familiar deja vu. The same thing was said about build's execution element, with one difference: you cannot bind a report to another page. Sorry. Here you can see more project information. Several elements do not affect the build, but rather document the project for the convenience of developers. Many of these elements are used to fill in project details when generating the project's website. However, like all POM declarations, plugins can use them for anything. Followings are the simplest element: name, description, URL, inception. Here, name. Project tend to have conventional names beyond the artifact ID. The Sun engineers did not refer to their project as Java-1.5, but rather just called it Tiger. Here is where to set that value. Description, a short human readable description of the project. Although this should not replace formal documentation, a quick comment to any readers of the POM is always helpful. URL, the project's homepage. Inception year, the year the project was first created. Licenses are legal documents defining how and when a project or parts of a project may be used. A project should list licenses that apply directly to this project, and not list licenses that apply to the project's dependencies. Organization. The most projects are run by some sort of organization, business, private group, etc. Here is where the most basic information is set. Developers. All projects consist of files that were created at some time by a person. Like other systems that surround a project, so to do this, people involved with a project have a stake in the project. Developers are presumably members of the project's co-development. Note that although an organization may have many developers, programmers as members, it is not good form to list them all as developers, but only those who are immediately responsible for the code. A good rule of thumb is, if the person should not contacted about the project, they do not need to be listed here. Contributors are like developers, yet play an auxiliary role in a project's lifecycle. Perhaps the contributor sent in a bug fix or added some important information. A healthy open source project will like to have more contributors than developers. In the environment settings, in the issue management, this define the defect tracking system, Bugzilla, TestTrack, ClearQuest, etc. used. Although there is nothing stopping a plugin from using this information for something, it's primarily used for generating project documentation. Continuous integration management. Continuous integration build system based upon triggers and timings such as hourly or daily have grown in favor over manual builds in the past few years. As build systems have become more standardized, so have the systems that run the trigger those builds. Although the majority of configuration is up to the specific program used, continuum, cruise control, etc., there are a few configurations which may take place within the POM. Maven has captured a few of recurring settings within a set of notifier elements. A notifier is a manner in which people are notified of a certain build status. Mailing lists. Mailing lists are a great tool for keeping in touch with people about project. Most mailing lists are for developers and users. SCM, the software configuration management, so-called the source code control management, or succinctly Version control is an integral part of any healthy project. If your Maven project uses a SCM system, it does, doesn't it? Then here is where you place that information into POM. Prerequisites. POM may have certain prerequisites in order to execute correctly. The only element that exists as prerequisite in POM 4.0.0 is the Maven element, which takes a minimum version number. Repositories. Repositories are collection of artifacts which adhere to Maven repository directory layout. In order to be a Maven repository artifact, the POM file must live within the structure $base underscore repo / group ID / artifact ID / version / artifact ID - version.pom. $base underscore repo can be local file structure or remote base URL. The remaining layout will be same. Repositories exist as a place to collect and store artifact. Whenever a project has a dependency upon an artifact, Maven will first attempt to use a local copy of the specified artifact. If that artifact does not exist in the local repository, it will then attempt to download from the remote repository. The repository element within a POM is specify those alternate repositories to search. Plugging repositories are home to two major types of artifact. The first are artifacts that are used as dependencies of other artifacts. These are the majority of artifacts that reside within central. The other type of artifacts is plugins. Maven plugins are themselves a special type of artifacts. Because of this, plugin repositories may be separated from other repositories, although I have yet to hear a convincing argument for doing so. In any case, the structure of plugin repositories element block is similar to the repositories element. The plugin repository element each specify a remote location where Maven can find new plugins. Distribution management. Distribution management act precisely as it sounds. It manages the distribution of the artifact and supporting file generated throughout the build process, starting with the last element first. Repository. Whereas the repositories element is specified in the POM the location and manner in which Maven may download remote artifact for use by current project. Distribution management specifies where and how this project will get a remote repository when it is deployed. Repository element will be used as for snapshot distribution if the snapshot repository is not defined. Site distribution. More than distribution to the repository, distribution management is responsible for defining how to deploy the project site and documentation. And relocation projects are not static; they are living things. A common thing that happen as project grow is that they are focused to move more suitable quarters. For example, when your next widely successful open source project moves under the Apache umbrella, it would be good to give users a heads up that the project is being renamed to org.apache.my-project:1.0. Besides specifying new address, it is good form to provide message explaining why. Profiles. A new feature of POM 4.0 is the ability of a project to change settings depending on the environment where it is being built. A profile element contains both an optional activation, a profile trigger, and a set of changes to be made to the POM. If that profile has been activated, for example, a project built for test environment may point to a different database than that of the final deployment, or dependencies may be pulled from different repositories based upon JDK version used. The element of profiles are there. Activations are the key of the profile. Power of profile comes from its ability to modify the basic POM only under certain circumstances. Those circumstances are specified via an activating element. The base built element set, if we revisited, the reasons for two types of built element reside in fact that that does not make sense for a profile to configure built directories and extension as it does in the top level of a POM. Regardless of in which environment the project is built, some values will remain constant, such as directory structure of a source code. If you find your project needing to keep two sets of code for different environments, it may be prudent to investigate refactoring project into two or more separate projects. Here you can see POM, and you can see POM relationships. Under that you can see coordinates. Under that you can see group ID, artifact ID, and version. You can see on aggregation, and you can see modules under that, and you can see inheritance under POM relationships. Here you can see parents, dependency management, and under dependencies you can see dependency management and dependencies. Here you can see project information under POM, and you can see name, description, URL, inception year, licenses, developers, contributors, and organization under project information. Here you can see build system under POM, and you can see properties, packaging, build, and reporting under build system. Here you can see build environment under POM, and you can see environment information, Maven, and Maven environment under build environment. You can see issue management, CI management, mailing list, and SCM under environment information. And you can see pre-request, repositories, distribution management, profiles under Maven environment. And you can see repositories, plugin repositories, and repositories and plugin repositories under repositories. And you can see profile under profiles, and activation and suffix elements under profile. Here you can see element may be overridden, at least mostly by profile element settings. Here modules, dependency management, build, reporting, repositories, plugin repositories, distribution management, and profile elements that are the asterisk dash suffix element here under profile. These are the element contains element meant for inheritance. Here you can see dependency management and build. Here you can see the super pom is always the base parent. The super pom all Maven projects POMs extend the super POM, which defines a set of defaults shared by all projects. The super pom is a part of Maven installation. Depending on the Maven version, it can be found in the maven-x.y.z- etc.jar or maven-model-builder.xy.z.jar file in $ open curly brace m2 underscore home close curly brace / lib. If you look in this jar file, you will find a file named pom-4.0.0.xml under the org.apache.maven.model package. It is also published on the Maven reference site that is available on each version of Maven separately, and for example Maven 3.1.1, it can be found on the Maven model builder documentation. Here you can see inherit from. So com.company.killerapp-stores 1.0-snapshot is inherit from here, and com.mycompany killer app-api 1.0-snapshot and com.mycompany killer app-model 1.0-snapshot are inherit from these three inherit from com.mycompany killer app 1.0-snapshot, and this is this inherits from superpom here. Here you can see the default lifecycle bindings packaging pom. Here you can see the phases and the plugin goals here, this package, and install, deploy. Here you can see the plugin bindings for packaging. Here you can see the Maven install plugin install and Maven deploy plugin deploy. Here you can see this diagram shows what is pom. Here you can see the pom.xml here. Pom or project object model is the basic unit of Maven. Pom is actually an XML file that contains all the configuration and information which is useful to build the Maven project. Inside pom, the configurations which are specified are nothing but the dependencies and goals that can be executed. You can specify some other information as well inside pom, like project version, developers, mailing list, etc. Here you can see the pom.xml here, and here you can see the pom project object model is connected to pom, and here project object model interacts with dependency manager. Dependency manager is connected to repositories, and project object model and dependency manager interacts with project lifecycle. Project lifecycle interacts with plugins. Plugins interacts with source code, generated code, resources, binary files. Sorry, actually plugins are connected to source code, generated code, resources, and binary files. Here you can see the advantages. Here the main advantage of pom.xml are when you declare the required dependency inside the pom.xml, then the Maven download all the required dependencies in the form of a jar. It will be available to to Java class path in Eclipse IDE, for example. You can also add new libraries to projects. You don't have to search anywhere to download the files. Maven automatically download all the required files for the given version from the Maven central repository. It can work in IDEs, in the CI servers, as well as on the command line. Here you can see Maven reads, step 1 reads pom.xml. Then the download dependencies into the local local repository. 3 the execute life cycles, build phases and or goals. Then executes plugins, all execute according to the selected build profile. Here you can see Maven is connected to pom file via reads pom.xml. Within the pom you can see build life cycles. It has goals and phases and goals, and dependencies, jars, build plugin and build profiles. Dependencies, jars are connected to Maven local repository. Here you can see the visual of plugin element. The types of plugin, broadly plugins are of 2 types. Build plugins configured in pom for project pom under the build element. Such plugins are executed as part of the default build lifecycle. Reporting plugins configured as the project poms under reporting element. Such plugins are executed as part of the site lifecycle. Furthermore, plugins can be classified as core plugins where goals are bound to the core phases. Clean, compile, install resources, etc. Packaging plugins related to output artifact packaging. Examples include plugins EAR, Java, etc. Reporting plugins related to the site lifecycle and used to generate reports. Examples include check style, Javadoc, project info, reports, etc. Tooling plugins related to general tooling during the Maven execution. Examples include assembly help, enforcer, tools chain, etc. Plugin from Maven versus custom plugins. The official Maven plugins developed as part of the Apache Maven have standard naming convention. Plugin short name plugin. This naming convention is reserved should not be used by plugins which do not have a group ID of org.apache.maven.plugins and are not found on the Maven repository under org/apache/maven/plugins directory. Plugins developed with other group IDs typically have the name of plugin short name -maven -plugin. Standard plugins from Apache Maven have consistent site structure under common site https maven.apache.org plugins index .html. Each plugin landing page has a few menu items under its navigation panel. Introduction page which provide an overview of the plugin. The goals page which lists all goals defined by the plugin and a deep explanation of goals intent. The usage page provides configuration options and any relevant information regarding constraint for the plugin. An FAQ page is for responses for frequently asked questions. There are additional pages for license and download of the plugin as well. In addition to the standard menu items, the plugin landing page can provide links to examples and project documentation. The plugin site is the best way to start understanding plugin provided by Apache Maven. Plugins developed by external to Apache Maven should attempt to follow the similar conventions to ensure easier implementation by users. How to use plugins in the project POM. The plugins are configured in POM under either build or the reporting or the profiles, then profile element. The plugin can be located using standard Maven GAV group artifact version coordinates. In addition to the location coordinates, the plugin has few other elements that are optional. Extensions, the extension flag to an extension. The extensions is a flag to determine if Maven extensions from the plugin should be loaded. The value is true or false. However, the current data type in the schema is a string. for some technical reasons. The default value is the false, and it is rarely enabled. Typical use cases for enabling this is when defining custom lifecycle or packaging types. Inherited is a boolean flag that is true by default. As with extension, the data type in the schema is a string. Setting inherited to false prevent propagation of the configuration to any child pom of the current one. Executions. The execution is a complex element and contains set of execution elements. As its core, Maven executes such definitions. The execution specifies the set of goals to execute defining during the life cycle. The execution is a complex element that has a unique ID, phase, a phase to bind, and one or more goals to an inherited flag, similar to the one defined for a plugin, and also set as a string data type. The goals element, which is set a string goal element that are bound to the phase, and the generic configuration element. Dependencies. Dependencies is a complex element and contains a set of dependency elements. The dependency defines the listed the dependency elements. Configuration is a complex element which allows for a free form DOM configuration used by the plugin. Configuration specified specifics are typically listed and recommended in case of custom plugins in the usage page for a given plugin. Plugin inheritance. Plugins have inheritance logic similar to dependencies. A plugin declared in a parent pom is inherited into the child pom unless the parent declared inheritance flag to false. Setting the inheritance flags to false break the inheritance. In addition, the plugin management section in the pom functions the same way of dependency management works for a dependency. There's currently no equivalent in a build of materials for a plugin, although there is an open source issue for introducing such facility. Mixing Maven plugin, not officially an Apache Maven plugin, but the mixing -Maven plugin deserved a special mention. The plugin allows for including multiple plugin management sections without needing to inherit the plugins from a single parent. Using this plugin allows a build behavior to be made more modular. Here you can see the Maven pom plugins. Here you can see group ID, artifact ID, version, extensions, and inherited. Here the executions, and under execution and execution is there, and under execution ID, pace, inheritors, and goals, and configuration. Under goals you can see goal. Here you can see dependencies and configuration. Here we are considering how does Maven assemble the effective pom. An effective pom is an assembly of execution steps, properties, and profiles. The content that match that Maven can execute for a project, and an exhaustive set of dependencies and plugins needed for such an execution. Determination of any transitive dependencies of independencies, full depth imaginable, any conflict resolution in terms of dependency version. How does Maven assemble the effective pom? Maven assemble its effective pom by traversing the layers that act as building blocks. Each layer used has the ability to override or enrich the content of what become the effective pom. Maven internal defaults and super poms are built built into the Maven installation, so ideally not subject to customization. The layers below the global settings and user settings are, as their name suggests, inclined towards the hosting and overriding any settings for Maven. The parent bill of material and project pumps are where Maven instructions can be customized. Default values above the layers are utilized if no customization is made. Now we are going to explain the layers. They're going through the layers here. Maven internal defaults. This layer is within the Maven's own code unless the intent is to modify the Maven source code. It is safe to assume that the default are not modifiable. The location is internal to the Maven installation. Maven superpom. This superpom exists in the Maven own code. Once again, unless the intent is to modify Maven's own source code, it is same to assume that the superpom is not modifiable. Location is internal to the Maven installation. Maven global settings. The Maven one Maven is installed or unarchived on a computing device. It creates a directory structure. One of these base directories listed base directories is conf. This directory contains settings.xml referred to as global settings file. Since this file extent exists on the local computing device, it is editable. Typically, any settings that apply to all projects being managed on the computing device are managed in this global settings.xml. Examples may include proxy settings, corporate server URLs, mirrors, etc. It should not often be modified in any case. Location is in Unix and Mac OS. Maven installation /conf/settings.xml. In Windows, Maven installation /conf and /settings.xml. Maven user settings, similar to global settings but at a different location. It is possible to create a user settings file. This file is also named settings.xml, but it is its location is under user home in an .m2 directory. The purpose of the user settings.xml is to set up any settings that apply to projects managed by a specific user. There could be multiple users on a given computing device. Examples include the usernames and passwords to connect to network, repository ordering, etc. Locations, Unix or Mac OS, user.home /m2./settings.xml. In Windows, user.home for /m2/settings.xml. Parent or build of materials pumps. Maven has an inheritance and version trait model. Maven can inherit content from and version traits from a build of materials POM. Typically, parent POMs contain reusable dependencies, plugins, and properties used by a project POM. The build of material POM is a specialized POM that allows group together dependency versions of dependency that are known to be valid and tested to work together. Using BOM POM reduces the developer grief from having to test compatibility of different dependencies. Modification of either is possible if there is a need and entitlement to change. Since changes to either can impact several other projects, appropriate version increment and reviews are recommended for changes. The locations is various locations either on device or elsewhere in some repository. Project POM, this is the project object model for the project. Project specifies specific Maven instructions are detailed in this location. Typical content include a unique set of coordinates used to identify the project name and description of the project, a set of developers associated with the project, any source control management details specific to the project, all project specific dependencies and plugins, any profiles that allow for alternative executions of Maven on this project, and so on. All this will be covered in the file containing this POM is by convention named pom.xml, but other names can be used. If an alternative name is used, then the Maven executable will need to be pointed to the file name of for the execution. The location Unix or Mac $project /pom.xml. In Windows $project /pom.xml. Here you can see effective pom here, and here you can see Maven internal default. Each lower section overrides the prior values. Maven super pom, base pom, all other poms inherited this pom. Maven global settings located in the config directory under the Maven installation directory. Maven user settings located in the .m2 directory under the user home directory. Parent or bill of materials poms, inheritance and trait structure for project poms to inherit from. Maven project pom, content of the project pom, and here you can see effective pom. Here you can see hierarchies, pom hierarchies. Here we are going to describe the hierarchy of Maven poms. Parent pom. The parent pom is a pom from which the current project pom can be inherited. For the project current pom can inherit content. The project pom can depend on exactly one parent pom. This single parent inheritance is one way. The parent pom is unaware of the poms that inherit from it. Here. The single parent inheritance is one way. The parent pom is unaware of the pom that inherits from it. The child pom declares the parentage in its own pom.xml. The standard file to hold the pom can be customized to a different name. Any number of poms can declare another pom as their parent. Usage, while we will delve into the content in the future. The parent pom can be used to declare reusable portions of the pom that individual child pom can inherit. This helps in both maintenance and to reduce clutter. Aggregator pom. The aggregator pom, also known as reactor pom, that can sequence the build of many projects. An aggregator pom specifies all the projects that can be built, managed together. The child poms, remain unaware of the aggregator poms that invoke it. A child pom can be listed in more than one aggregator poms. The aggregator poms list the child pom by name in its own pom.xml as a module. As the declared module suggests, this pattern is for modular builds of projects. There is no inheritance of any content from the aggregator pom. Usage, while the aggregator pom can be used to ensure the sequence of build and maintain a list of projects that should be built, managed together. Build of materials pom. Build of materials pom is a pom that can declare bundles of dependencies that have been tested to work well together. The abundance of artifacts and versions of each can at times lead to confusion and needs for trial and error mechanism to determine compatibility or might right functionality. A build of material poms reduces that overhead. Build of material pom is a means of multiple inheritance too. Since a project pom can import multiple build of material poms, the build of material poms is unaware of the child poms that import it. The child poms declare full declare the build of material in the project pom. Usage while this will the build of material poms can be used to bundle well working dependencies with right versions together to avoid repetition for every project. The pom can be both parent as well as aggregator. This allows for a two-way relationship in a tightly knit set of modules that depends on a common set of inheritance content. Here you can see pom hierarchies. Here you can see percentage. Yeah. Here the parent is connected to another parent. Parent pom is connected to another parent pom via dependencies, plugins, properties, and another parent pom is connected to here the project pom via dependencies, plugins, and properties. Here the child knows the parent, and parent doesn't know the child. Here you can see the aggregation. Here the aggregate pom is interact with the pom. Here the pom 1, project 1 pom, project 2 pom, project 3 pom, and project 4 pom via no inheritance of contents. The child does not know aggregator, and aggregator knows child. Here you can see the build of materials. Here the build of materials pom is connected to project 1 pom, project 2 pom, project 3 pom, project 4 pom. Likewise, the project poms via dependencies, plugins, and properties. Here the child knows build of Here the child knows build of materials. The build of materials does not know the child. Here we are considering transitive dependencies. With direct dependencies, the things you use yourself in your own code for the own code, and transitive dependencies things so here in the direct dependency, things you use yourself in your own code. For the transitive dependencies, things others use for things you use, pulled in recursively. Here you can see that your code is connected to direct dependency A, direct dependencies. Here the A and B, and here the direct or transitive dependency Z, and here the direct dependency B is connected to direct or transitive dependency Z. Here your code and direct dependency B is connected to direct or transitive dependency Z. Here the direct dependency is connected to transitive dependency TA and TB, and here the transitive dependency TB and direct dependency B is connected to transitive dependency TC. Now we are considering bill of materials BOM. Larger projects like Payakara, Amazon, SDK, etc. provide list of direct dependencies. This comes in handy when adding these dependencies transitive for us as a direct dependencies like here. Here you can see your POM, and your POM is connected to your POM inherits Maven super POM, and your POM import is connected to some BOM via import, and some BOM is depend on direct and transitive dependency. and here the your pom depend on some version, direct and transitive dependency here. Here you can see the parent pom and super pom. Any project may be a child of a parent. Project silently inherit from super pom, which is a global Maven standard parent pom. Children may also be aggregated by a parent without them knowing, or for convenient built for larger projects. Here you can see any pom inherits Maven super pom, and parent one pom inherit Maven super pom, and parent one pom aggregate submodule 1 pom and submodule 2 pom here. Now here you can see the parent pom and super pom. The children may children may inherit dependencies, properties and settings and plugins, etc. from parents, making it possible to share common ground. Both apertures may combine, may be combined. The children may import as many bombs as they want, but can have only a single parent to inherit from at a time. Here you can see a parent pom inherits Maven super pom. Here the parent pom aggregates submodule 1 pom and submodule 2 pom here, and submodule 1 pom inherits parent, and submodule 2 pom inherits parent pom, and here the dependency here inherit is parent submodule 1 pom is connected to dependency via inherit depends on, submodule 2 pom is connected to dependency via inherit depends on, and parent pom is connected to dependency via depends on. Here you can see transitive dependencies. Maven is compatible. Maven is comfortable for developers. It handles recursive resolution, downloading and adding and dependency of dependencies. However, as lifecycle of a box coordinate, you might find yourself in version conflict hell sooner or later without knowing, but experiencing unintended side effect. When you look at the topmost in this case here the version 2.0 will be included. If you know something about semantic versioning, the red alert should ring in your mind right now. How do we know that B is compatible with Z version 2.0 when depending on Z version 1.0? Another scenario getting us in trouble, a direct use of transitive dependencies. Imagine the following: we rely on Z in our code, but do not include a direct dependency for it. Within the pom. Now assume B is updated and removed its dependency on Z. You definitely don't want to head down that road. Follow the rules to be safe. 1. Do not use transitive dependencies implicitly. Add the direct dependency for transitive depths you reuse in your code. To the even on every build, check that no implicit usage was added by accident. 3. Explicitly declare versions of transitive dependencies in use of multiple direct dependencies. On every build, check that there are no converge problems hiding in the shadows. 5. Do special test on every build to verify these explicit combinations work. You can manage versions of transitive dependencies in 4 ways. One is explicitly declare transitive dependency in dependency management within the version tag. That's a good and safe practice. And 2 is for more complex transitive dependency, use bill of materials BOM within dependency management. Many bigger projects provide them, making the POM much less bloated compared to adding every bit yourself. That's a safe and good practice. And 3, using optional and exclusion tags on direct dependency that request the transitive dependency. Last resort, you really should avoid this, not explained or used here. It's better to avoid or don't. And 4, make transitive only dependency not use in code and direct use one and add version tag. Typically bad idea, don't do that. And this is another better avoid or don't. And here you can see your code is connected to direct dependency B, and here set version 2.0 and direct dependency B is connected to shared version 1.0 here. Here you can see a short comparison with Ant in Maven dependency management. What is the difference between Maven dependency management and Ant dependency management? First of all, the Ant only manages project build phases, delegating dependency management to Apache Ivy. This works together. Therefore, the two tools handles a different task in details. First, the Ant runs built from build.xml file. Ivy downloads dependencies written in a list inside ivy.xml file into local repository. On the other hand, the Maven manages both aspect build phases and dependencies starting from a single file called pom.xml. The actually the Maven has built-in phases that can be managed by developer from pom.xml. On the other hand, working with Ant phases must be created from build.xml. Here you can see here the Ant project root directory. Here the build.xml is connected to contain the description of build phases, and here ivy.xml is connected to contains dependencies list. Here the Maven project root directory, and here the pom.xml is connected to contains description of build phases and the dependencies list. Here you can see the structure of the pom.xml file. The POM file is an XML file that contains all project information and instruction for Maven program Maven to build the project. Here's a quick description of POM file with the main section and how to fill them. Again, here you can see the parent POM reference. This is optional, and here you can see Then we are coming to artifact definition and description. Here you can see the artifact ID, the unique ID name, no uppercase character and space. Group ID, unique group ID, institution name, no uppercase character and space. Version number, format is major.minor, patch add dash snapshot suffix for in progress version. Here you can see the packaging, name, description, URL, organization, licenses, developers, etc. Here you can see a build definition. The instruction used to build the project, Java compiler, version, inclusions, exclusion, or inclusions or exclusions patterns, specific specific jar generation. Lot of things can be done here. Here the list of dependencies, all dependencies required by the projects. Here the external repositories, links, external repository links and deployment information. Give the give target link for third-party artifacts and target link for uploading the artifact on the Maven server. Here you can see the version requirements have the following syntax in dependency version requirement specification. Dependencies version element define versions requirements which are used to compute dependency versions. Soft requirements can be replaced by different versions of the same artifact found elsewhere in the dependency graph. Hard requirements mandate the particular version or versions and over soft requirements. If there are no versions of the dependency that satisfy all hard requirements for that artifact, the build fails. The version requirements have the following syntax. Here the soft requirement for 1.0 and use 1.0 if no other version appears earlier in the dependency tree. Here the hard requirement for 1.0 use 1.0 and only 1.0. Here the hard requirement for any version less than 1 point less than or equal 1.0. Here the hard requirement for any version between 1.2 and 1.3 inclusive. Here the 1.0 less than grade less than or equal x less than or equal and less than or equal 2.0. The hard requirement for any version between 1.0 and inclusive and 2.0 exclusive. Hard requirement for any version greater than or equal to 1.5. Hard requirement for any version less than or equal to 1.0 then or greater than or equal to 1.2 but not 1.1. Multiple requirements have separate commas. Here the hard requirement for any version except 1.1. For example, because 1.1 has the critical vulnerability, Maven picks the highest version of each project. Maven picks the highest version of each project that satisfy all the hard requirement of the dependencies on that project. if no no version satisfies all the hard requirements, the build fails. Now as an example, we can consider the minimum requirement for a POM are following. The minimum requirement for a POM are following here: project, root, model version should be at least should be set to 4.0.0 with this version, and group ID, the ID of the project's group, artifact ID, the ID of the artifact project, the ID of the artifact project, version, the version of the artifact under the specified group. The POM requires that it's a group ID, artifact ID, and version be configured. These are three values from project's fully qualified artifact name. This is in the form of group ID colon artifact ID colon version. As an example, we can consider here com.mycompany.app colon my-app colon 1. Also, if configuration details are not specified, Maven will use their defaults. One of these default values is the package type. Every Maven package, every Maven project has a package name, package type. If it is not specified in the POM, then the default value jar would be used. Furthermore, you can see that in the minimal POM here, the repositories are not specified. If you built your project using the minimal POM here, it would inherit the repositories configuration in the super POM. Therefore, when Maven uses the dependencies in this minimal POM, it would know that these dependencies will be downloaded from https repo.maven.apache.org.maven2, which has specified in the super POM. As an example 2, we can consider this one, the plugins. Here, beyond the standard coordinate of group ID colon artifact ID colon version, there are elements which configure the plugin or these builds interact with extensions, true or false, whether or not to load extensions of this plugins. It is by default false. Extensions are inherited, true or false, whether or not this plugin configuration should apply POMs which inherit from this one. Default is true. Configuration, this is specific to individual plugin. Without going too in depth into the mechanics of how plugin works, suffix it to say that whatever properties that the plugin mojo may expect, these are getters and setters in the Java mojo bin, for example, can be specified here. In this example, we are setting the classifier property to test maven dash jar.plugin in mojo. it may be good to note that all configuration elements, wherever they are within POM, are intended to pass values to another underlying system, such as a plugin. In other words, values within configurations element are never explicitly required by the POM schema, but the plugin goal has every right to require configuration values. Dependencies are seen a lot within POM and are an element under all plugin element blocks. Dependencies have the same structure and function as under the base build. The major difference in this case is that instead of applying as dependencies of the project, they now apply as dependencies of the plugin that they are under. The power of this is to alter the dependency list of a plugin, perhaps removing an unused runtime dependency via exclusions, or by altering the version of a required dependency. Executions. It is important to keep in mind that the plugin may have multiple goals. Each goal may have a separate configuration, possibly even building a plugin goal to a different pace together. Executions configure the execution of a plugin goals. For example, suppose you wanted to bind the ant_run goal to the verify pace. We want the task to echo the build directory as well as avoid passing on this configuration to its configuration, assuming it is a parent by setting inherited or false. Now we are considering the field static final pom here in interface type in package org.apache.maven .api. Now we are considering package org.apache.maven.api.model, Maven immutable pom, project object model classes generated from Maven.mdo model. The root class is model. Now we are considering interface super pom provider in package org.apache.maven.api.services, provides the super pom that all models implicitly inherit from. Now we are considering Maven. This is reference for the Maven project descriptor used in Maven. The project in Maven, this element is the root of the descriptor. It has elements like group ID, artifact ID, version, relative path. With regarding API, the interface project in package org.apache.maven.api interface representing a Maven project. Projects can be built using project builder service. Parent, this element contains the parent element contains information required to locate the parent project from which this project will inherit from. Not the children of this element are not interpolated and must be given as literal values. With regarding API, the class parent in package org.apache.maven.api model, the parent element contains information required to locate the parent object from which the project will inherit from. Not the children of this element are not interpolated and must be given as literal values. Organization specifies the organization that produces this project. With the API class organization in package org.apache.maven.api.model specifies the organization that produces this project. License, describe the licenses for this project. This is used to generate the license page of the project's website, as well as being taken into consideration in other reporting and validation. The licenses listed for the project are that of the project itself and not of dependencies. The class license in package Maven.api.model describe this the licenses for this project. This is used to generate the license page of the project's website, and as well as the being taken into consideration in other reporting and validation. The licenses listed for the project are that of the project itself and not of dependencies. Developer information about the one of the committers on this project. The class developer in the regarding API, the class developer in package Maven.api.model, information about one of the committers on this project. Contributor, description of a person who has contributed to the project but who does not have commit privileges. Usually these contributors come in the form of patches submitted. Class regarding API, class contributor in package Maven.api.model, description of a person who has contributed to the project who does not have commit privileges. Usually these contributions come in the form of patches submitted. Mailing list, this element describes all of the mailing list associated with the project. The auto-generated site references this information. The class mailing list in package Maven.api.model. This element describes all of the mailing list associated with the project. Auto-generated site references this information. Pre-request describe the pre-request a project can have. Class pre-request in package Maven.api.model describe the pre-request a project can have. SCM, the SCM element contains information required to the SCM source control management of a project. Regarding API, the class SCM in package Maven.api.model. The SCM element contains information required to the SCM source control management of the project. Issue management, information about the issue tracking or bug tracking system used to manage this project. Class issue management in package Maven.api.model. Information about the issue tracking or bug tracking system used to manage this project. CI management, the CI management element contains information required to the continuous integration system of the project. The class CI management in package Maven.api.model. The CI management element contains information required to the continuous integration system of the project. The notifier configures one method for notifying users or developers when the build breaks. Class notifier in package Maven.api.model configured one method for notifying users or developers when a build breaks. Distribution management, this element describes all that pertains to distribution for a project. It primarily used for deployment of artifact and the site produced by the build. Class distribution management in package Maven.api.model. This element describes all that pertains to distribution for a project. It is primarily used for deployment of artifact and the site produced by the build. Releases. The download policy. With regarding API, the method at not null public deploy repository dot builder releases repository policy releases in class deployment repository dot builder in package Maven.api.model. Snapshots is a download policy, and in regarding API at not the method at not null at non null public deployment repository dot builder snapshots repository policy snapshots in class deployment repository dot builder in package Maven.api.model. Relocation describe where an artifact has moved to. If any of the values are omitted, it is assumed to be the same as it was before. Class relocation in packaged API.model describe where an artifact has moved to. If any of the values are omitted, it is assumed to be the same as it was before. Dependency management section for management of default dependency information for use in a group of POMs. Regarding API, the class dependency management in package API.model section for management of default dependency information for use in a group of POMs. The dependency element contains information about dependency of the project. The class dependency in package org.apache.maven.api.model. The dependency element contains information about the dependency of the project. Exclusion, the code, the exclusion element contains information required to exclude an artifact to the project. The class exclusion in package org.apache.maven.api.model. The exclusion element contains information required to exclude an artifact to the project. Built. The built element contains information required to build the project. Default values are defined in a superpom. Regarding API, the class built in package org.apache.maven.api.model. The built element contains the information required to build the project. Default values are defined in the superpom. Extension. Extension describes built extension to utilize. With regarding API, the class extension in package org.apache.maven.api.model describe built extension to utilize. Resource. This element describe all the class path info resources associated with the project or unit test. With regarding API, the class resource in package org.apache.maven.api.model model. This element describe all of the class path resources associated with the project or unit test resource. This element describe all of the class path resources associated with the project or unit test. With regarding API, the method at non-null public build.build test resources, collection resource, test resources in class build.build in package org.apache.maven.api.model. Plugin management section for management of default plugin information for use in a group of POMs. With regarding API, the class plugin management in packaged org.apache.maven.api.model section for management of default plugin information for use in a group of POMs. Plugin, the plugin element contains information required for a plugin. The class plugin in package org.apache.maven.api.model. The plugin element contains information required for a plugin. Execution, the execution element. The execution element contains information required for execution of a plugin. With related to API, the class plugin execution. In the package org.apache.maven.api.model, the execution element contains information required for execution of a plugin. Reporting. Section for management of reports and their configuration. With regarding API, the class reporting in package org.apache.maven.api.model. X section for management of report and their configuration. Plugin. The plugin element in contains information required for a report plugin. Regarding API, the class plugin in package org.apache.maven.api.model. The plugin element contains information required for a plugin. Report set represent a set of reports and configuration to be used to generate them. With regarding API, the class report set in package org.apache.maven.api.model represent a set of reports and configuration to be used to generate them. Profile modification to the build process, which is activated based on the environment parameters, so command line arguments. Regarding API, the class profile in package org.apache.maven.api.model, the modification to the build process, which is activated based on the environment parameters, so command line arguments. Activation. the conditions within a built runtime environment which will trigger the automatic inclusion of a build profile. Multiple conditions can be defined which must be satisfied to activate the profile. Regarding class API, the class activation in package API.model, the conditions within the built runtime environment which will trigger the automatic inclusion of build profile. Multiple conditions can be defined and which must be all satisfied to activate the profile. OS, this is an activator which will detect an operating system's attribute in order to activate its profile. Class with regarding API, the class activation OS in package Apache.maven.api.model. This is an activator which will detect an operating system's attribute in order to activate its profile. Property, this is the properties specification used to activate the profile. If the value is an empty, then the extension of the named property will activate the profile. Otherwise, it does case sensitive match against the property value as well. With regarding API, the class activation property in package Apache.maven.api.model. This is the property specification used to activate the profile. The value field is empty. Then the extension of the name property will activate the profile. Otherwise, it does not. Does the case sensitive match against the property value as well. File. This is the file specification used to activate the profile. The file value is the location. The missing value is the location of the of a file that needs to exist, and if doesn't, the profile will be activated. On the other hand, the exist will test for an existence of the file, and if it is there, the profile will be activated. With regarding API, the class activation file in package Apache.maven.api.model. This is the file specification used to activate the profile. The missing value is the location of the file that needs to exist, and if it doesn't, the profile will be activated. On the other hand, the exist will test for existence of the file, and if it is there, the profile will be activated. Build, the build configuration in a profile. The class built in package Apache.maven.api.model. The build element contains the information required to build the project. Default values are defined in the super POM. Now we are considering what is POM in introduction to POM. The example for this is the build directory with the file regarding the file structure, which is the target, the source directory, which is the source main Java, the test source directory, which is source test Java, and so on. And a project object model, or POM, is a fundamental unit of work in Maven. It is an XML file that contains information about the project and configuration details used by Maven to build the project. It contains different default values for most projects. Example for this is the build directory, which is the target, the source directory, which is source main Java, and the test directory, which is source test Java, then and so on. When executing a task or goal, Maven looks for a POM in the current directory. It reads the POM, gets the needed configuration information, then executes the goal. Some of the configuration that can be specified in the POM are the project dependencies, the plugins or goals can be executed, the build profile, and so on. Other information such as project version, description, developers, mailing list, and such can be specified. Now we are considering a super POM. You can see the super POM for Maven 3.6.3 in Maven core reference documentation. This is a segment of it. The super POM is Maven's default POM. All POMs extend the super POMs unless explicitly set, meaning the configuration specified in the super POM is inherited by the POMs you created for your projects. Now we are considering minimal POM. Here is an example. The minimum requirement for a POM are following here. project root, module version should be set to here 4.0.0 here. Group ID, the ID of the project's group. Artifact ID, the ID of the artifact's project. Version of the artifact under the specified group. Here's an example. Prompt requires its group ID, artifact ID, and version be configured. These three values from the project's fully qualified artifact name. This is in the form of group ID, colon artifact ID, colon version. As for the example here, its fully qualified artifact name is pom.company.app colon my-app colon 1. Also, as mentioned before, if the configuration details are not specified, the Maven will use their defaults. One of those defaults values is the packaging type. Every Maven project has a packaging type. If it is not specified in the POM, then the default value jar would be used. Furthermore, you can see the minimal POM, the repositories were not specified. If you build your project using minimal POM, it would inherit the repositories configuration in the super POM. Therefore, the Maven sees the dependencies in the minimal POM. It would know that these dependencies will be downloaded from https://report.maven.apache.org/maven2, which was specified in the super POM. We are considering example in project inheritance. The example com.mycompany.app colon my dash module colon 1 pom. Here as an example, let us reuse the artifact. This one, the com.company.app my dash app 1 colon 1, and let us introduce another artifact com.mycompany.app colon my dash module colon 1. Here this one, and let us specify their directory structure as the following. They note the my dash module /pom.xml is the pom of the com.company.app colon my dash module colon 1, while the pom.xml is the pom of the com.company.app colon my dash app colon 1. The solution is here. Now if we were to turn the com.mycompany this one .app colon my dash app to 1 into parent artifact of the com.mycompany.my dash module colon 1. So we'll have to modify the com.mycompany.app.my module colon 1's pom in the following configuration. This is com.mycompany.app colon my dash module colon 1's pom. Notice that we now have an added section, the parent section. This section allows us to specify which artifact is the parent of our POM, and we do so by specifying the fully qualified artifact name of the parent POM. With this setup, our module can now inherit some of the properties of our parent POM. Alternatively, you can now if you want the group ID or version ID, group ID or the version of your modules to be the same as your parent, you can remove the group ID or version identity of your module in its POM. This allows here this one. This allows the module to inherit group ID or version of its parent's POM. Now we are considering project example in project aggregation. Here the with related to the previous scenario with the previous original artifact poms and directory structure, here the com.mycompany.app colon my dash app colon 1 once pom here, and here the com.mycompany.app my dash module my module colon my dash module colon 1, and here the directory structure. The solution is here. Then if we want to aggregate my module into my app, we would only have to modify my app. In the revise com.mycompany.app my dash app colon 1, the packaging section and the module section were added. For packaging, its value was set to pom, and for module section we have the element module, my dash module. The value of module is the relative path from the com.mycompany.app colon my dash app colon 1 to com.mycompany.app colon my module colon 1 once pom. By practice, we use the module's artifact ID as the module's directory name. Now whenever a Maven command processes com.mycompany.app colon my dash app colon 1, that same Maven command would be run against the mycompany.app colon my dash module colon 1 as well. Furthermore, the some commands goal specifically handle project aggregation differently. Now we are considering project inheritance versus project aggregation. Here you can see com.mycompany.app colon my dash app colon 1's pom. Given the here the com.mycompany.app colon my app colon 1 once pom. Here this one, and here the com.mycompany.app colon my dash module colon 1 pom. This is the and this directory structure. This is my module here. The solution is the to do the both project inheritance and aggregation. You only have to apply all three rules. The three rules are: specify every child POMs in who their parents POMs is, and change the parent POMs packaging to value POM, and specify parent POMs directories in its modules. Here the here the com.mycompany.app colon my dash app colon one's POM here. And here the com.mycompany.app colon dash dash my module, the my dash module and colon one's POM. Now we are considering special variables in available variables in project interpolation and variables. Here the the format of the Maven build timestamp can be customized by declaring the property maven.build.timestamp.format as shown in this example. The Maven build.timestamp maven.build.timestamp the timestamp that denotes the start of the build UTC since Maven 2.1.-M1. The format pattern has to comply with the rules given in the API documentation for simple date format. If the property is not present, the format default to the value already given in the example. Here you can see a quick overview in POM reference. This is a listing of the element directly under POM's project element. Notice that module version contains 4.0.0. That is the currently only supported POM version and is always required. The basics, the build settings, more project information, environment settings, now we are considering basics. This is unlike a build.xml file where the tasks are almost always dependent on the lines executed before it. The POM contains all necessary information about the project, as well as configuration of plugins to be used during the build process. This is a declarative manifestation of the who, what, and where while build lifecycle of when and how. That is not to say the pom cannot affect the flow of the life cycle. It can, for example, by configuring Maven ant run plugin, you can embed Apache ant task inside the pom. It is ultimately a declaration, however, whereas a build.xml tells the ant precisely what to do when it is run procedural. The pom states its configuration declarative. If some external force causes the lifecycle to skip and the ant plugin execution, it does not stop plugins that are executed from doing their magic. This is unlike a build.xml file where the tasks are almost always dependent on the lines executed before it. Now we are considering Maven coordinates in basics. This marks a specific place in the repository, acting like a coordinate system for Maven projects. The project defines before bare minimum that allows the group ID dot artifact ID group ID colon artifact ID colon version are all required fields, although group ID and version do not need to be specifically defined if they are inherited from a parent. The three fields act much like an address and timestamp in one. This makes a specific place in a repository, acting like a coordinate system for Maven projects. Group ID. This is generally unique amongst an organization or a project. For example, all core Maven artifacts do well should live under the group ID or apache.maven. Group IDs do not necessarily use the dot notation. For example, JUnit project, note that the dot notation notated group ID does not have to correspond to the package structure that the projects contain. It is, however, a good practice to follow. When stored within the repository, the group ID acts much like the Java packaging structure does in operating system. The dots are replaced by OS-specific directory structure such as / in Unix, which becomes a relative directory structure from the base repository. In the example given, the org.code host.mojo.group Mojo group lives in the directory $m2 underscore repo / code host /mojo. Artifact ID. The artifact ID is the generally name that the project is known by. Although the group ID is the important, people within the group will rarely mention the group ID in the discussion. They are often all be the same ID, such as Mojo host project group ID, org.code host.mojo. It along with the group ID creates a key that separates this project from every other project in the world. At least it should. Among with the group ID, the artifact ID fully define the artifact's living quarters within the repository. In the case of above project, my project lives in $m2 underscore repo / code host / mojo / my project. Version. This is the last piece of the naming puzzle. Group ID colon artifact ID denotes a single project, but they cannot delineate which incarnation of the projects we are talking about. Do we want the JUnit of 2018 version 4.12 or the 2007 version 3.8.2? In short, code changes, those changes should be versioned, and this element keep those versions in line. This is also used within an artifacts repository to separate versions from each other. My project version 1.5 files live in the directory structure $m2 underscore repo / org / code host / mojo / my project 1.0. The three elements given here point to a specific version of a project. Letting Maven know who we are dealing with, and when it's software lifecycle we want to use we want them. Now we are considering packaging. We could make it into a var by declaring a different packaging. In API, the method at not null public model dot builder packaging string packaging in class model dot builder in package or apache dot api dot model. Now we have addressed the structure of group ID colon artifact ID colon version. There is one more standard label to give us really complete what that is the project's packaging. In our case, the example pom for org.codehost.mojo colon mojo colon my dash project colon 1.0 defined above will be the package dash previous one as jar. We could make it into a var by declaring a different packaging. When no packaging is declared, Maven assumes the packaging is the default jar. The valid types are plexus role hints. Read more on plexus for explanation of roles and role hints of the component role. org.apache.maven.lifecycle.mapping.lifecycle mappings. The current core packaging values are pom, jar, maven dash plugin, egb, var, er, rar. These define the default list of goals which execute on each the corresponding build lifecycle stage for a particular package structure. Now we are considering dependencies in POM relationships. As an added bonus, the Maven brings on the dependencies, those dependencies, transitive dependencies, allowing for your list to focus solely on the dependencies your project requires. With the API, we can consider at not null public model.builder dependencies collection dependencies in class model.builder in package org.apache.maven.api.model. The cornerstone of the POM is its dependency list. Most project depends on others to build and run correctly. If Maven does for you is the manage this list, you have gained a lot. Maven downloads and links the dependencies on compilation, as well as other goals that require them. As an added bonus, Maven plugins in the dependencies of those transfer dependencies, allowing your list to focus solely on the dependencies your project requires. Group ID and artifact ID and version. You will see this element often. This trinity is used to compute the Maven coordinates of a specific project in time, demarcating it as a dependency of this project. Purpose of this computation is to select the version that matches all the dependency declaration due to transitive dependencies. There can be multiple dependency declaration for the same artifact. The value should be group ID and artifact ID directly corresponding to the group coordinates of the dependency, and version, the dependency version requirement specification that is used to compute the dependency's effective version. Since the dependency is described by Maven coordinates, you may be thinking this means that my project can only depend upon the Maven artifact. Answer is of course, but that's a good thing. This focuses you to depend solely on dependencies that Maven can manage. There are times, unfortunately, when a project cannot be downloaded from the central Maven repository. For example, the project may depend on a jar that has a closed source license which prevent it from being a central repository. There are three methods for dealing with this scenario. One, install the dependency locally using install plugin. The method is simplest and recommended method. To create your own repository and deploy it there. This is a favorite method for companies with the intranet and Need to be able to keep everyone sync. There is a Maven goal called deploy-deploy-file, which is similar to the install:-install-file goal. Read the plugins goal page for more information. 3. Set the dependency scope to system and define the system path. That's not recommended, however, but leads to us to explaining the following element. Classifier distinguishes the artifacts that were built using from the POM but differ in the content. It is the same optional and arbitrary string that % is appended to the artifact name just after the version number. As a motivation for this element, consider for example a project that offers an artifact targeting Java 11, but at the same time it's also an artifact that still supports Java 1.8. The first artifact could be equipped with the classifier JDK 11 and the second with the JDK 8, such that client can choose which one to use. Another common use case for classifiers is to attach secondary artifact to the project's main artifact. If you browse the Maven Center repository, you will notice that the classifier sources and Java docs are used to deploy the project source code and API docs along with the package class files. Type corresponds to the chosen dependency type. Default to jar. When it usually represents the extension on the file name of the dependency, that is not always the case. A type can be mapped to a different extension and a classifier. The type often corresponds to the packaging used, though this is also not always the case. Some examples are jar, ejb-client, and test-jar. New types can be defined by plugins that set extensions to true. So this is not a complete list. Scope. This element refers to the class path of the task at hand, compiling and runtime testing, etc., as well as how to limit the transitivity of dependency. There are 5 scopes available. Compile. This is the default scope used if none is specified. Compile dependencies are available in class paths. Furthermore, those dependencies are propagated to dependent project. Provided. This is much like compile but indicates you expect JDK or a container to provide it at runtime. It is only available on compilation and test class path, and it's not transitive. Runtime. The scope indicates that the dependency is not required for compilation but is for the execution. It is in the runtime and test class path but not in compiled class path. Test. This scope indicates that the dependency is not required in the normal use of application, but it's only available for the test, compilation, and execution phases. It is not transitive. And system. This scope is similar to provided, except that you have to provide the jar which contains it explicitly. Artifact is always available and is not looked up in the repository. System path. Use only for dependency scope is system. Otherwise, the build will fail if this element is set. The path must be absolute, and so it is recommended to use the property to specify the machine specific path, such as $ open curly brace java.home closing curly brace /lib. Since it is assumed that the system scope dependencies are installed in a priori, Maven does not check the repositories for the project, but instead check to ensure that the files exist. If not, Maven fails the build and suggests that you download it and install it manually. Optional marks the dependency optional. When this project itself is a dependency. For example, imagine a project A that depends upon project B. To compile a portion of code that may not be used at runtime, then we may have no need for a project B for all project. If so, the project X adds project A as its own dependency, then Maven does not need to install project B and at all. The symbolically, if / greater than sign represent required dependency and dash greater than sign represent optional, although A equal and greater than A lead to B may be the case when building X to A to B would be the case building X. In the shortest terms, optional lets other projects know that you use this project and do not require this dependency in order to work correctly. Now we are considering properties. Their values are accessible anywhere in the POM by the using notation here, the $x, where the x is the property, or they can be used by plugins as default values, for example. In API, the public the method at non-null public model.builder properties map string properties. The properties are the last required place to understand POM basics. Maven properties are value placeholders like properties in ANT. Their values are accessible anywhere within POM by using a notation $sign and here the open curly brace x of close curly brace where x is a property, or can be used by plugins as default values, for example here. They come from 5 different types. One is the env.x. Prefixing a variable with env will return the shell environment. For example, $env path contains the path environment variable. The project .x a dot notated path in the POM will contain the corresponding elements value. For example, project version 1.0 is accessible via project.version. Settings.x a dot notated the path in the settings.xml will contain the corresponding elements value. Java system properties, all properties accessed via java.land.system.get properties are available as POM properties such as open curly brace java.home close curly brace x set with the within properties element in the POM. Following project properties are reserved for Maven will become elements in future POM definition. Don't start your POM on properties with project. Here we are considering base built element set in built settings. Base built is exactly as it sounds, the base set of element between two built element of the POM. Here the default goal the default goal of op is to execute if none is given. If a goal is given, it should be defined as it is in the command line such as jar::jar. The same goal for Same goes for the if a paste is defined, such as install. Directory, this is the directory where the build will dump its file, or in Maven parlance, the build's target. It aptly default to $ open curly base close curly base target directory. Final name, this is the name of the bundle project when it is finally built. Sans the file extension, for example, my-project 1.0 jar. It default to $artifact ID and $version. The term file name, term final name is a kind of misnomer. However, as plugins that build the bundled project have every right to ignore or modify its name, but they usually do not. For example, if the Maven jar plugin is configured to give you a jar, a class classifier of test, then the actual jar defined above will be built as my-project 1.0 test jar. Filters, filter defines *properties files that contain list of properties that apply to resources which accept their settings. In other words, the name equal value pairs defined within the filter files replace $open curly base name close curly base strings within resource on build. The examples here defines the filter.properties file under the filters directory. Maven's default filter directory is $based directory /source then /source /main /filters. Now we are considering licenses in more project information. Licenses are legal documents defining how and when the project or parts of a project may be used. Regarding API, we can consider @not-null, the method @not-null, public model.builder licenses, collection licenses in class model.builder in package of api.model. Licenses are legal. A project should list licenses that apply directly to this project and not list licenses that apply to the project's dependencies. Name, URL, and comments are self-explanatory and have been encountered before it in other context. Using an SPDX identifier as the license name is recommended. The fourth license element is a distribution. This describes how the project may be legally distributed. The two standard methods are repo. They may be downloaded from the Maven repository, or manual. They may be manually installed. Now we are considering issue management in environment settings. Although there is nothing stopping the plugin from using this information for something, it's primarily used for generating project documentation. This defines the in the class with regarding API, the class issue management in package apache.maven.api.model. Information about the issue tracking or bug tracking system used to manage this project. This defines then the defect tracking system, Bugzilla, Test Track, Clear, Quest, etc. used. Although there is nothing stopping the plugin from using this information for something, it is primarily used for generating project documentation. Now we are considering the final. The Maven POM is big, however its size is also a testament to its versatility. The ability to abstract all of the aspect of a project into a single artifact is powerful, to say the least. Gone are the days of dozens of disparate build script and scattered documentation concerning each individual project. Along with Maven's other stars that make up the Maven galaxy, a well-defined build lifecycle, easy to write and maintain, plugin centralized repository, system-wide and other user-based configuration, as well as the increased number of tools to make developers' jobs easier to maintain complex projects. The POM is a large but bright center. Now we are considering profiles in external files, in which areas of a POM can be customized by each type of a profile and why, and in introduction to build profile. Profile specified in external files, that is in settings.xml or profiles.xml, are not portable in strictest sense. The class with regarding API, the class settings in package maven.api.settings, the root element of the user configuration file. Profiles in external files, profiles specified in external files, that is in settings. So profiles.xml are not portable in a strict sense. Anything that seems to stand a high chance of changing the result of a build is restricted to the inline profile on the POM. Things like repository list could simply be a proprietary repository of approved artifact and won't change the outcome of the build. Therefore, you will only be able to modify the repositories and plugin repository sections plus the extra properties section. The properties section allows you to specify freeform key value pairs, which will be included in the interpolation process for the POM. This allows you to specify a plugin configuration in the form of $open curly brace profile.path close curly brace. Now we are considering profiles in POMs. The profile specified in POMs can modify the following POM element. On the other hand, if your profiles can be reasonably specified inside the POM, you have many more options. Trade-offs, of course, that is that you only modify that project and its submodules. Since these profiles are specified inline there, and therefore they have a better chance of perceiving portability, it is reasonable to say you can add more information to them without risk of having information being unavailable to other users. Profiles specified in the POM can modify the following POM elements: repositories, plugin repositories, dependencies, plugins, properties not actually available in the main POM but used behind the scenes, modules, reports, reporting, dependency management, distributed management, a subset of built element which consists of default goal, resources, test resources, directory, final name, filters, plugin management, and plugins. POM element outside profiles. We don't allow modification of POM elements outside of POM profiles because this runtime modification will not be distributed when POM is deployed to the repository system, making the versions built of that project completely unique from others. While you can do this to some extent with the options given for external profiles, the danger is limited. Another reason is that the POM info is sometimes being reused from the parent POM. External files such as settings.xml and profiles.xml also do not support element outside the POM profiles. Let us take a scenario for elaboration. When the effective POM is deployed to an remote repository, any person can pick up its info out of the repository and use it to build Maven project directly. Now imagine that if we can set profiles in dependencies which are very important to a build and any other information outside the POM profiles in the settings.xml, the most probably we cannot expect someone else to use the POM from the repository and be able to build it. And we have to also think about how to share the settings.xml with others. Note that too many files to configure are very confusing and very hard to maintain. Bottom line is that since this is built data, it should be in the POM. Now we are considering bill of materials bombs on POMs. Imports are most effective when used for defining a library. In POMs, and the other projects have wished to use the library should import this POM into dependency management section in their POM. Imports are most effective. So in the API, we can consider class dependency management in package overload.apache.maven.api model section for management detailed dependency information. Imports are most effective when used defining a library of related artifacts that are generally part of multi-project build. It is fairly common for one project to use one or more artifacts from these libraries. However, it has sometimes been difficult to keep versions of the project using artifact in sync with the version distribution library. Pattern below here allows how build of materials BOM can be created for use by other projects. The root project is the POM. It defines versions of all artifacts that will be created in the library, and other projects that wish to use the library should import this POM into dependency management section in their POM. The parent subproject has the POM as its parent. It is a normal multi-project POM. And the next actual project's POMs. Sorry. The project as follows shows the library that can be used in another project without having specifically dependent on versions. Finally, when we create projects that import dependencies, beware of the following. Do not attempt to import POMs that define a submodule of the current POM. Attempt to do this will result in failing, since it won't be able to locate the POM. Never declare POMs importing a POM as parents or grandparents, etc. of the target POM. There is no way to resolve the circuitry, and exception will be thrown. When referring to artifact, those POMs have transitive dependencies. The project needs to specify versions those artifacts are as managed dependencies. Not doing so result a build failure, since artifact may not have been version specified. This should be considered best practice in any case, at least keep versions of artifacts from changing from one build to next. Sorry, this one DOM, and here artifact. here the this one, and the and here the artifact ID is project 1 here. Now we are considering guide to create create the prototype files and the prototype pom.xml in guide to create archetypes. Next, the component of the archetype to be created is an example for a prototype pom.xml is here. Then the next the archetype to be created is the prototype pom.xml. Any pom.xml will do. Just don't forget to the set artifact ID and group ID variables $sign open curly brace artifact ID close curly brace $$ open curly brace group ID close curly brace. Both variables will be initialized from the command line when calling archetype generate. An example for a prototype pom.xml is here. Now we are considering injecting pom property settings.xml in plugin configuration and injecting pom properties via settings.xml in example. We have plugin parameter that should contain a user specific value. This parameter have a common format creative directory structure, but depend on knowing the directory of the install application or something. Here the project configuration is here. Here you can see the settings .xml. When Maven loads the project pom, it will pick up the activated profiles from the active profiles section of the settings XML settings.xml file and inject properties declared within the profile. When pom is interpolated, the application -home property will already been injected, so it will allow the plugin parameter value to be resolved. Now we are considering project the project descriptor pom pom requirements in a introduction in Mojo API. The pom must declare a packaging element which describe this project as a Maven plugin project. Here you can see a packaging Maven -plugin. With regarding API, we can consider the method at non-null public model.builder packaging string packaging in class model.builder in package of Apache.maven.api.model. Now we are considering POM code conventions in XML in Maven code style and code conventions. The following is the recommended ordering of Maven POM files. The team has voted during the end of June 2008 to follow a specific POM convention to order POM element. The sequence of this vote is that the Maven project descriptor is no more considered as the reference for ordering. The following is the recommended ordering of Maven POM files. The comments, the project element is always on one line. The blocks are voluntarily separated by a new line to improve readingness. 3. The dependencies on in the dependencies in dependencies and dependency management tags have no specific ordering. Developers are free to choose the ordering, but grouping dependencies by topic like grouped ID, that is org.apache.maven, is a good practice. This should be in one line, obviously. An example we can consider, this one occurred in the environment with pipeline of a Java project and Git repository. Not found Maven POM file. Error unhandled. Not found Maven POM POM file /home /vsds /work /1 /s pom.xml. Finishing Maven pom.xml.